Lempar bola.
Make lots of things. Okay, you can make a robotic arm with the help of this servo. Okay, so but a robotic, what you mean by joint? Okay, so for example, this is my arm. Okay, so I have a joint here. This side. Okay, so this is my hand, and this is my joint. Okay, so it can move up to, okay, so 90, and this is 90, around 70. Okay, so we can move around 180 degrees. Okay, the same way, if a robotic arm is there, if their hand is there, we can make a robot hand to move in 180 degrees. Okay, so we are going to see this servo. Okay, so let's make its program. Okay, so I will explaining you in the real time also, and I am explaining you with the Tinkercad also. Okay, so let's first go to our Tinkercad, and there we will make the circuit, and there we will run it, and after that we will do it on in reality. Okay, so let me stop sharing my camera, and I will start sharing my. Okay. So now what we need is, okay, so now what we need is we need to, okay, so this is a servo which I have made. Okay, I just delete it and reassemble. We are going to run a servo motor. Okay, let's continue. Okay, so just I delete it, and I will assemble it once again. Okay. Now what? I am speaking loudly only. Okay. So okay, so this is our Arduino. Okay. Now we need to take a servo. Okay, so you can write like this. Servo. Okay. So when you type servo, you will get a servo. Click here, and you will get. You can make his first. Okay, I will try to speak a little higher. Okay. So okay, now it's fine. Okay. So first thing we need is we need to connect the 5 volt. Okay, so our sensor have 3 pins. Okay, so now what? Okay, so our sensor have 3 pins: ground, power, and signal. Okay, so first we need to connect the ground. Ground is connected to ground. Okay, and this servo operates on 5 voltage. Okay, so we need to give it a 5 volt. So first we take 5 volt from here. Okay, take it up. Okay, and here, then here, and then. So we will provide it first a 5 volt. Right. Okay. Then we need to bring a ground. Okay, so there is a ground. Okay, now on the last we have a signal wire. Okay, so I'm connecting with pin number 9 to the signal wire. So then I'm connecting pin number 9 with the signal wire. Okay, so we have 3 colors. Okay, the first color is orange. Sorry, first color is brown. Brown indicates ground. Okay, second is red. Red indicates 5 volt, and third is orange. Orange indicates a signal. Okay. So what we are doing is we are powering this servo motor, and we are controlling the servo motor by pin number 9. Okay, so what we are doing till now, we are controlling LEDs, We're controlling sensors. We are taking input from the sensor. We are giving output to the motors, output to the LED. Now we are giving output to this special type of motor. Okay, this is our task. Okay, let's do coding. Okay, so I'll just clean all this previous things. Okay, so okay, so we have done with the color coding. Now we need a special type of library for it. Okay, so we need to include this library which is called inc include. Okay, so we need to include a library because without this library, this motor will not work. Okay, so we have include servo dot h servo dot h. Okay, so we have the servo dot h. After servo dot h, we have okay. Okay, so we have selected the library. Now we need to give it a. We need an integer. Okay, so we need that pin number. Okay, so we are using pin number 9. So we say servo pin. Okay, so we have this servo pin. Okay, and we are giving servo pin number 9. Then we need to give it int servo pose. Okay, so we are giving the position for the servo. Okay. I'll tell you what is all about, but we need to define two variables. We are defining two variables. First variable is to hold the pin name, and second variable is to hold the degree, how much degree we want to rotate it. Okay. So first I am giving it a 0 degree. Okay. Now we need an object. Okay. So what an object can do? Okay. So object, understand, object is a type of container which can hold the value, which can hold this servo properties. Okay, so it is a type of object. Object means anything. So if you talk about the talk about the phone, it is an object. Okay, it has some properties, some functions. Okay, so what is happening? I'm speaking very high. My God. One second. Hello, hello. It's okay now. Hello. Still, it is low. It's low or no? Guys, I think it is not breaking. Okay. So we have servo and we are making it object. Guys, don't disturb unnecessarily. Okay. My servo. Okay. Servo equals to my servo. Okay. So we are define an object name as servo. Okay. So like a human being, we have some properties. Same. So, like a human being, we have some properties. In the same way, this object has some properties. Okay. So, what properties it have? This object will have. It will contain all the function which is performed by a servo motor. Okay. So, we make my servo. If you hook many more servo, for example, you have two servo or three servo, you can just change the name servo my one, servo my two, and servo my three. Okay. But for what single motor we are using, I'm speaking at my best. Hello. Yeah. I have not spoken a single word. Why my voice is breaking? It's some stupidity. Okay. So we have created an object. Okay. After creating an object, this object can do all the function which is done by her. Okay. I'm not seeing any of the message. Very irritating, unnecessary. Okay. So we have created my server. Okay. After creating my server, we need to make a void loop. Okay. So what this void setup? Okay. So we set everything up that is required to make our circuit. Okay. So we have void. Okay. Void setup. And after that, we have a loop. Okay. And in this void setup loop, we set dot begin. Okay. So we are seeing. Okay, so we are beginning the serial monitor at a baud rate of 9600. Okay, it's the speed at which serial monitor communicates. Okay, and we are defining the object. So we are saying my servo, that is our object. Servo. Okay, it's saying my servo dot write. Okay, so we are writing my servo dot attach. Okay, so we are attaching attach servo in. Okay, now we have void loop my servo dot write. Okay, so we are writing the server how much it needs to be rotated. Okay, then we are taking it back to the position we can that we have make a variable which is called servo. Okay, so we are making that variable servo. Okay, so we are using that variable my servo position. Okay, servo position. Okay, we have created. Guys, don't be a mess. Okay, okay, you have a bad air flow. Okay, there is a problem at your end. Some are getting, some are not getting. That is not problem. You have a problem at your end. Stop writing now. Okay. So we are using this void loop and we are setting servo position. Okay. So we have set it the servo position and I am okay. So this is done. Now we need to run it and see how it's going to run. Okay. So suppose I want to make it 50. Okay. So we have this 50 and our servo will set it 50. I'm starting the simulation. See. Okay. Let's see why it is not showing. Tinkercad is showing us some errors, and we cannot find it out what error it has here. Okay, what we will do, we'll copy this. Okay, copy this, and I will go into my this Arduino ideas, because it gives me a little better prospection about the error. So I just paste it here. So there is something which we have missed. It's going to help us. It's saying that you can define the scope. We have this S. Okay, so we have this S capital. Nothing is changed. Okay, now so let's compile it again. Take this. Okay, let's see. Okay, it's showing me something else. One second. Showing some error. Okay, let's see more. Something is okay. So okay, reconnect to yourself. Okay, those who are getting those who are getting disturbance in the network, please re-enter. Okay, everyone. Otherwise, it will not work properly. Okay, so re-enter once again. So you can have that. Okay, so it's showing me some errors, including servo.h. Okay, then we have it. We have taken a we have checked also in this log check. Okay, let's go to find. Okay, we will use the two things. Okay, then we will let as a servo also. Servo.pin. Okay, okay. Let's see if it is 9. Let's see.
Sir, my also error coming. I have
Yeah.
also I have also tried on computer.
Hmm.
Uh, Same
Okay.
error is coming. Sir,
Okay.
please give me that I can show you screen sharing
No,
option.
no, I will do it. Okay, don't need to use it. So I'm
Sir,
just
I
okay.
have put the same coding which you have shown in your computer.
I am also getting error, no? I'm
Yes,
solving out
sir.
that. Okay, let's see that, how we can change things. Okay. Right. Okay, we are writing down the same thing, but it's okay. So let's just copy this syntax. I think there might be a syntax error, and this is change it. Okay. So we have initial position. Okay, I'm changing it to 50. Okay, and I'm attaching to 9. Okay, and I'm still moving all these things, moving all these things. Okay. So our code is same at we have the last. Okay, so now let me compile it. So it's done. It is right code. Okay, so we can use it. Okay, so there is same thing, nothing changed. Sometimes it happens. We missed a single word. Okay, so that's why it's not coming. Okay. I think it is done now. Okay. So we can use this code. Okay, it's now error free. Let me just make it a little bit more specific about it. Okay. So we'll go into the Tinkercad and I just copy paste. So we have done the same thing, including the servo.x. Then we have make a servo object, okay, and we have made a starting position 50. Okay, now they are not defining the pin number 9. Okay, so they are not defining the pin number 9, and we were defining the pin number 9. Okay, so first we try to run this. Okay, if this run, uh, you can see our motor is running. Okay, it will be running towards 90 degree. Okay, then it will stop. Okay, so it is somewhere 90. The servo doesn't move always all the time. Okay, but it is 90. So let's make this code a little bit more better. Okay, so we are using here the variable now. Okay, so we cite servo position pin. We can write pin. So we can say pin, and here we can define int pin. Okay, we are using pin number 9. So we'll say int pin 9. Okay, the same code is. So now we will write this position. Okay, and we will have a. So we'll rotate it. Okay, so we have position 1 and position 2. Okay, so we have position 1. In the position 1, we will make it 0. Okay, so we have position 1 will make it 0, and in position 2, so in position 2. Okay, so we have position 2, and we are making it, suppose we make it 100. Okay, and we make it, and we say delay, delay, and we will have we set in here. Okay, and after that, okay, then we will write it. My servo dot write. Okay, and we will write uh, position 2, position 2, and here we have a position 1. Okay, and after that writing the position 2, we writing the position 1, we will have a delay of, okay, 500 milliseconds. Okay, so what we are doing is we are just using the motor to go left, right, left, right, left, right. Okay, so how much degree we are turning it to the 100 degree. So it is, for example, it is here, then it's turned back. Suppose this is our servo motor. Okay, so the this is the gear of our servo motor. Okay, so it is somewhere here. Okay, it's 0. Okay, so when it goes to 100, okay, so I just make okay. So I think you all know degrees. Okay, so this is 30 degree. Okay, okay, somewhere is a 30 degree. Then we have 60. Sorry, then we have 60. Okay, then we have straight is 90. Okay, so 100 is somewhere here. Okay, and this is 180. Okay, so what we are doing is we are rotating this motion. Okay, so we're starting with 0 degree. Okay, so our motor is somewhere here. Okay, and it will move. It will move in this direction 200 degree here. Okay, so it depends upon the circle position. Okay, so it might be a 0 and it might be 100, but it will start rotating in one direction. And after when the thing is gone, it will hold there for 500 milliseconds. After that, it will again come back to its direction. It will come back here, back. Okay, so in this way, it will rotate this way and rotate that way. Okay, let's see, just clear everything. Okay, let's see it in action. Okay. Okay, we have this. Okay, so it's moving. Okay, it's 0, it's 100, it's 0, it's 100. Okay. So it is moving between 0 and 100, and it is waiting for 5 milliseconds. Yes. So
Sir, your voice is too low.
my voice is low.
Yes, sir, very low. I can't hear it.
Okay, so I will just do one thing. I will leave and come back. It might be error. Might be a network issue. So I just okay. Okay. So let's see the code again. Okay. So we are including the servo.h library. Without this library, you cannot access the function of this Arduino. Okay. So what this library have, it has all the code which is required to use this servo. Okay. So instead of writing 100 code again and again, they have provided you header file. So you can easily make your code of 10 to 20 lines. Okay. So what we have done, okay.
Yes, sir.
Yeah, say,
Sir, there was a student named Krupa with some bad words had written, and in the chat he has given bad words.
uh, guys, don't write bad words in the chat. Okay.
Sir, I have taken screenshot also.
Um, okay, we'll see it. Guys, okay. So now everybody stop doing chatting, okay, and concentrate here, okay. So what we are doing is we are including this library. This library itself has some many codes. We can access with the help of this keyword called include servo.h. Okay, so we are accessing this server with the help of this library. After that, we will make an object. Okay, so create an object to control the server. Okay, so what is an object? So in reality, what is an object? Object has a state. Okay, and it has a space. Okay, it occupies space and have a mass. Okay, so anything which has a mass and occupies space is called an object. Okay, so that is the basic definition of an object. Okay, or a matter you can say. But here in the virtual world, object is type of container. Okay, so it is a container which not only contain the values and the data but also contain the functions. Okay, so what the functions are? Suppose we are a human being. What we can do? We can see, eat. Okay, and we can do certain things. Okay, so these all are our functions. In the same way, this my servo, this is a keyword and this is the name given to it. Okay, so this can able to do many things which can servo motor can do. Okay, so it can change its position. Okay, so suppose if you see here we have my servo dot write. Okay, it means it is saying that my servo is an object can write. What can write? Of writing means doing something. Okay, writing means doing upward, giving the output. Reading means taking the input. Okay, so what my servo is doing? My servo is writing. Okay, it is writing. It is writing. It is doing out, giving the output. What output is giving? It is giving position. Okay, so position is zero. It is going to the 0 degree. Statement means going to the 0 degree. Okay, and this statement is the same statement, but we are changing the position to 0 to 100 degree. Okay, so this object has function which is to move according to the degree. Okay. After that, we have initialized two integers. Okay, so integer means a number. So we have 0 and 100. Okay, so anyone can ask, sir, why we have not written 0 and 100 here. Okay, so you can write 0 and 100 here. But if suppose your code is so long, if I have to move the servo 10 degree, 20 degree, then 10 degree, 20 degree, suppose there is 100 line of code, you cannot go and change again and again 0, 100 and 10. Okay, so I need to change here only, and in the rest of the program, the keywords is going to be changed. So variables is going to be changed. Okay. Then we have a void setup. Okay. So in the void setup, we are initializing that we have attached the server. Okay. So this object is attached to pin number 9. Whatever you are going to do is going to do with pin number 9. Okay. And after that we have using this. Okay. We have what we have done in the while loop. While loop means it is continuous. When first instruction will be executed, then second instruction will be executed, third instruction will be executed, fourth instruction is executed, then again first instruction is executed. It is a while loop. Loop means it is continuous. It keep going. First, second, third, fourth, first, second, third, fourth, first, second, third. Okay, so it will go to 0, wait for half a second, goes to 100, wait for half a second. It's going like this. Okay, so let's see if we can do something better with it. Okay, so we will have now we will move this servo according to our desired position. Okay, so we have serial. Okay, let's use the serial number. Serial dot begin. Okay, and we have 9600 is our water. It's first so initiate the serial monitor. Okay. Now what we are going to do is we are writing a program in which okay first let me give you this one. Comment this. Okay. So your first program is server. Okay. So this is your first program and the first program server and I will display it. So it's the yeah. Okay. And this and it is to you have this. Okay. So we have this server. Okay. So now after that, after doing this, we will begin our serial monitor and we will use the serial monitor to do that thing. Okay. So we will use the serial monitor serial dot print serial dot okay let me uncomment this because we are going to use it. Okay. So we have serial dot print. Okay. So we are printing on the serial monitor. Print means giving the output as a text. Serial dot print. Okay, so we have serial dot print and we are printing what? Serial dot print ln. Okay, ln stands for new line character. Okay, serial dot print ln and we are telling something to the user. Okay, we are telling something to the user. User means you, what you want. So we want an system. Uh, we want servo to move with our desired position. So what servo angle? What angle? What is servo angle? Okay, so we'll ask the user what is servo angle. Okay, so user will tell what is servo angle. Okay, what is servo angle. After that, we will wait. Okay, so we will wait till the user press the enter. Okay, so while okay, and we have serial. Okay, we are reading from the serial monitor now. Okay, serial dot एक minute, 1 second. Available. Okay, so getting the serial dot available. Okay, and if it is available, then we have equals to 0. Okay, so okay, so this is a while loop. Okay, so while loop continues till it is wrong. Okay, so if the nothing is written, okay, so it is saying that serial dot available. Okay, something is present on serial monitor. If something is present on serial monitor, this loop will not run. Okay, so it is if something is not present on the serial monitor, this loop will run continuously and we will get no output. Okay, so after we get the output, okay, so when we have gotten the output, so what we need to do is so we have something called okay, so now we have position one. So we use the position one and we will set the position one according to the given statement. Okay, so we have now we will take the value from serial monitor. Okay, so serial dot okay, so it is instruction. Okay, so say and this is instruction. Okay, so it will take the value from the serial monitor and store in this variable. Okay, and with the help of this variable, we will change the server position. Okay, so I'm removing everything except position one. Okay, so we will get a position one from the serial monitor when we type, and then this program will be done. Okay, so let's see if it is right or wrong, or we have some syntax. Okay, the code has some error. Okay, let's see what errors we okay. happens sometimes we get an error. Copy this and go into our ideal. Okay, so before going to the ideal, let's see it in the reality, the previous code. Okay, so we'll see the previous code in reality, and we will able to do it. Give me a second. Control V. And just back. Before moving on, okay, so we have the server position. Okay, so we have one, and we have to let me complete this first. Then we will go to the next part. So we have this delay, and we have this tab. I just forget to show you on the real time. Let me test it once again. If it is right, then let's see. Okay, I've written that code in the text. Copy this, and we are going back to our IDE. Yeah, this. Let me check it. Zero initial position, pin number 9. Okay. My servo dot set attached to pin number 9. That's okay. Let's see that. Okay. So it is saying that unexpected. Okay, sorry. So we have just removed and okay. So you see how much a small mistake can affect your entire program. Okay. So what we are doing is we have just don't have put this colon. Okay, so see now I think it will work fine. Let's see. Okay, okay, some time, right? Okay. Now let's just check this in the real time. I will opening my camera, okay, stopping my screen, and showing you how to plug a serial monitor in and how to write on in hardware. Okay, so I just can show you my not this one, not this one. Here, I think it's right. Camera is not. Mhm. Yeah. So we have this camera. That is the good one camera. Okay, so this is our server. Okay, I just stop sharing. My screen will be enlarged. Just everyone click on my screen. Okay. Okay, so this is our server and it is rotating. You can see that. Okay. On to the server. Okay, so here somewhere. Okay. So this is the server. Okay, this is a real life server. Okay, so this is the server and it is rotating according to our program. So before doing that, show you what how I plug the connection. Okay, the connections are the same. Okay, so as you've seen in the Tinkercad circuit, the connections are same. Okay, so if we just talk about the connections, okay, so we are using three wires. Okay, this white wire is hooked in the orange wire here. Okay, so we have a junction. This orange wire is hooked with the white wire. Okay, so it is giving the signal. This is giving the signal, and this red and black wire is giving the power to the circuit. Okay, and it's moving. Okay, let's see. Uploading my code. Also, yeah. So this is our code. So I can go and you will see. Okay, so if I just how to upload a code. Okay, so first you need to select the code. Okay, so first you need to select the code. Okay, so we have this. Okay, this code. Okay, and we need to select the board. Okay, so I am using Arduino Uno. So if you are using Arduino Uno, click here. If you are using suppose Arduino Nano, Edmica, according to Arduino board. Okay, so there are huge number of Arduino board. Okay, so I'm using Arduino Nano, so I need to click here. Okay. After that, there is a symbol for uploadation. First, before uploading, you need to compile. We have compiled it and we have done compiling it. Okay. Now it's time to upload it. Okay. So I'm uploading it. Okay. So it's compiling. First, you can directly upload also. Okay. Because it itself gets compiling, then only it will put it into the machine. Okay. It's compiled, compiled. Okay. It's compiled and it's uploaded. Okay. See the speed of my server. It is very fast right now. 0 to 100 in no second, in no time. So to see that, because I have given not a delay. Okay, so it was suppose if I increase the delay. Okay, so it is 500 and I just give 1000. Okay, it's taking a time for 1000 in one side, and it's taking 1000 means 1 second. Okay, let's see how much it affects. Okay, so we are uploading back. Okay, okay, so everyone can hear the sound of servos like that. So they have gear inside it. Okay. Okay, so now we have connected it. Okay. So it's waiting for. Okay. So it's stopping. It's waiting for 1 second. Then it's going up. 0, 100, 0, 100. Okay. So if you want to increase the position. Okay. So if you want to make it not 100, not 100, we are going to make it 180. Okay. So from 0 to 180 of complete half rotation. Okay. So we download upload it once again. Yes, ma'am. Okay. Click on my computer. Click here. Okay. So when you see, I click on this. Okay. So when you click on this, you get a big view. Okay. So now see, it is moving 180 degrees. Okay. Complete 180 degree rotation. Got it. In this way, a servo is working. Okay. Thank you for today's class. I hope you like the servo. Bye. I have sent in you the code. The code is the same. Okay. You need to just